then in the third unit you have three-phase AC circuits, in which we will study about the power management in three-phase circuits. Then what is the relationship between the phase and line quantities? So all those things that we will study in the third unit of the chapter. But before that, we have introduction to AC circuits or steady state analysis to AC circuits, right? So in this chapter, basically we will talk about the performance of different single phase AC circuits. Means how, depending upon the different type of load connected in the system, the performance of the circuit or system changes. Like you know that there are mainly three types of electrical load in AC systems. First one is the resistive load, then inductive load, and then capacitive load. So normally more than 90% of the loads available in our electrical system is of inductive nature, right? RL load hota hai, a mixture of resistor and inductor, right? So most of the loads are inductive in nature. Whatever you consider, practical examples you may consider as a motor, means AC motors, whether it is single phase induction motor or three phase induction motors. Then you have this fan which is installed in our households, AC, fridge, whatever the load you see. So most of the loads are inductive in nature. So how these load behaves and what is the impact on the performance of the external system, that we are going to study in this chapter, right? So after the resistive, inductive, and capacitive load, we will also see the combination effect, that is the when the real loads, that is a mixture of resistive and resistance and inductance both are considered. Then what is the performance on voltage current, what is the relationship between voltage and current phasors, that we will see. Again, for resistive and capacitive load, what is the performance, then on the combination of resistance, inductance, and capacitance. So all these things we will cover in this chapter. So this is the very basic thing about any AC circuit. Electricity supply systems are normally AC in nature. So you know that whatever supply is coming to our household or to the society, that is in the form of AC, alternating, right? This AC supply voltage varies sinusoidal. So in this waveform here, in this figure, you can see that this voltage waveform, which is mentioned on the y-axis, magnitude of voltage, and on the x-axis, it is time. So you can see that there is a sinusoidal variation of voltage with respect to time. So normally AC voltages are expressed in this form: V is equal to Vm sine 2 pi ft or Vm sine omega t, where omega is 2 pi f, right? Vm is your peak voltage जो है maximum voltage, तो वो तो alternating, you can say this is alternating in nature, that is after each half cycle, this is your one half cycle, 1 by 2f, and this is the complete cycle, t is equal to 1 by f. So you can see that after each half cycle, the polarity of the voltage wave reverses. So if I ask you to calculate the average value of this AC voltage, so what will be the average value? Can you say? Hello? हेलो, आवाज नहीं आ रही है?
0
आ रही है
Okay. So if I ask you to calculate the average value, so its average value will be 0, because you can see that for the first half cycle it is positive in nature, having the same magnitude, and for the remaining half cycle it is negative. so the average value will be 0. So now the same circuit, if we consider a simple resistive circuit where a resistance is connected to an AC supply, this is the AC supply, having voltage Vm sin omega t. So when you will calculate the current, then it will be simply I is equal to V by R. So you will get this expression where Im is equal to your Vm by R. So obviously the magnitude of this current will be lesser than the magnitude of voltage at each instant of time. ठीक है, for different value of t, the magnitude of current will be less than the magnitude of voltage applied using the source, right? So that's why you can see that even if the voltage and the current, both the waveforms are in phase, दोनों जो है phase में है, voltage and current, but there is a difference in the magnitude of these two quantities, voltage and current, due to the inclusion of the resistance in the circuit, right? So for a resistive load or resistance in the circuit, pure resistance in the circuit, both current and voltage will be in phase. तो इसको अगर इस तरह से भी हम फेजर डायग्राम से भी रिप्रेजेंट करते हैं, so if V is the voltage, if we take V as the reference axis voltage, then current will also be in the same direction. Right, same phase में होगा. There will be zero phase difference between voltage and current. Now, before going to this, if we now suppose include any inductance in the circuit, अगर हम मान लो कि same circuit एक draw करते हैं, same circuit if we consider AC circuit, where we have a resistor and inductor both present in the system. Look, this is just the basic. I hope ये तुम लोग को पता है सब, but डिटेल में जाने से पहले हम लोग जो है सो आज यही देखेंगे कि क्या करंट वोल्टेज में रिलेशन होता है फॉर डिफरेंट टाइप ऑफ लोड्स कनेक्टेड टू द सिस्टम. So suppose here we have R and L both present in the system. Or it is better to mention XL, where XL is the inductive reactance and R is the resistance. So if same voltage we consider Vm sin omega t. So now can you draw the phasor diagram for this circuit? What will be the phasor diagram? So if by the same procedure, suppose if we take the reference on the reference axis, if we consider the voltage across the resistor VR on the reference axis, this is your VR, the potential drop or voltage drop across the resistor R. And if we take VL as the voltage drop in the reactor XL having inductance of L, then for this resistor, both voltage and current, suppose this is VR, so both voltage and current will be in the same phase if I is the current flowing through the circuit due to the voltage source V. So both VR and the current will be in the same phase as we have discussed for the previous case. But for this inductor, this voltage will lead the current by I. There will be a 90-degree phase difference between the voltage and the current in the system, because this is a lagging load. So the current will lag the voltage by 90 degree, right? Similarly, for a capacitive load, the voltage will what? उस केस में क्या होगा? करंट लीड करेगा.
लीड करेगा.
हेलो, कोई
Yes sir,
प्रॉब्लम है क्या?
lead करेगा. No sir, no sir, no sir.
Right. Okay, so current will lead by voltage. if it is a pure capacitor, then it will lead by 90 degree. Current will lead by 90 degree. So now, if for this circuit, we draw the complete phasor diagram, then what will be the case? So suppose if we consider VR, this VR, that is voltage drop across the resistor as the reference axis. So your IR is also in the, or I current flowing through the circuit will be also in the same phase. Then your voltage across the inductor will be in this direction VL, that is current will lag VL by 90 degree, and the resultant of these two, that is VR and VL, will be your complete voltage V. ठीक है, यहाँ सर्किट से भी अगर देखोगे इस सर्किट से, so your V, if you apply the KVL in this circuit, so what will be the KVL equation? Here you will get V will be equal to VR plus VL. Phasor summation will be there because this is a AC circuit, right? In case of DC circuit, जो भी अभी हम लोगों ने अभी तक पढ़ा है, whatever we have discussed in the DC network theory, that was a DC circuit. तो वहां पे arithmetic sum हो जाता था, but here you will have to take the phasor summation. That's why phasor diagram हम लोग बात कर रहे हैं, and there will be some phase difference between these two voltages. Let us consider it as phi, angle phi, right? So if we just consider the magnitude, then your magnitude of the voltage V will be VR square plus VL square, right? Where VR is your VR का क्या होगा value? VR will be equal to IR, then VL will be equal to J IXL. तो इसका magnitude लोगे तो simply it will be IXL, right? So you can perform the different analysis. Similarly, you can also calculate the value of this angle, phase angle, right, using this triangle. So all these things can be done. So now you can also draw this current and voltage relationship for this RL circuit. तो सिंपल R circuit के लिए, for simple resistive circuit, we have seen that both the voltage and current are in phase, but you can see that if we draw the voltage and current variation, suppose this is on the y-axis, we consider voltage and both current, and if we plot the variation of voltage and current with respect to time, so इसमें क्या होगा बताओ अगर हम V कंसीडर करते हैं Vm sin ओमेगा t, so simply I will be equal to how much? Current lag करेगा by some angle phi, so it will be simply Im sin ओमेगा t minus phi angle. ये जो phi angle कंसीडर किए, that is current is lagging the voltage, this V is the voltage by some angle equal to phi, right? So now if we take the voltage as the reference and we draw this variation sinusoidal voltage for a complete cycle, t is equal to 1 by f, right? So current का variation तब क्या हो जाएगा? करंट कुछ इस तरह से होगा, राइट? ये समझ में आया कि नहीं आया, ये पहले बताओ। Here you can see that if we have considered Vm as the peak value, then obviously the peak value of the current will be slightly less than Vm, as it was in the case of a simple resistive circuit, right? And apart from that, there is a phase difference of phi between the voltage and current. In the previous case there was no phase difference between voltage and current, but here due to inductive property of the circuit there is a phase difference between voltage and current. So this voltage is your V is equal to Vm sin omega t, and for this current you have Im sin omega t minus phi. Is it clear or not? First of all, tell me that.
Clear, sir.
Okay. तो ये ठीक है, चलो आगे बढ़ो. Now, for AC circuit, for any AC circuit, whether we are calculating the voltage and current in any AC circuit, then there are some terms which you have to consider or remember, like RMS value of voltage and current, then maximum value or peak value of the voltage and current, and also the average value, right? So कहीं भी देखते हो जो अगर कोई पैरामीटर किसी सर्किट में मेंशन किया रहता है इन टर्म्स ऑफ वोल्टेज एंड करंट आई एम टॉकिंग अबाउट. So in any AC circuit, if any voltage and current is mentioned, then you will have to consider that it is the RMS voltage or RMS current. जैसे कि suppose I will give you one practical example. In your household, कितना मतलब किसी के घर में कितना सप्लाई आता है, कितना वोल्ट पे सप्लाई आता है, ये बताओ. ये सबको पता होना चाहिए.
20.
Okay, so a single phase, in a single phase line, the rated voltage is 220 volt or 230 volt. ठीक है. So that is the RMS value of the voltage, right? And suppose if I talk about a three-phase AC circuit, then can you tell what is the value of voltage? जैसे कि लैब है, मान लो कि मशीन लैब में जहां तुम्हारा एक्सपेरिमेंट होता है तो वहां पे कुछ कुछ मशीन्स जो है वो थ्री फेज सप्लाई पे चलते हैं. जैसे कि अभी तो नहीं है तुम लोगों का वैसा, लेकिन आगे हो सकता है हो. इलेक्ट्रिकल वालों का तो होता है थ्री फेज इंडक्शन मोटर होता है, या थ्री फेज ट्रांसफार्मर होता है, या सिंक्रोनस जनरेटर होता है. तो दीज आर द मशीन्स व्हिच ऑपरेट्स एट थ्री फेज सप्लाई. So in three phase supply, the voltage level is 440 volt. जैसे कि बोलते होगे ना कि अरे 440 वोल्ट का जो है सो इसमें सप्लाई आ रहा है. जैसे कि घर में जो कनेक्शन आता है तो पोल पे देखते होगे, इलेक्ट्रिकल पोल पे 3 वायर रहता है. सो ईच वायर रिप्रेजेंट्स ए फेज. सो सपोज RYB और ABC जो भी होता है, तो देयर आर थ्री फेज. तो एक फेज से कहीं कहीं सप्लाई जो है जो तुम्हारे घर में आ जाता है. कोई कोई लोग दो फेज भी लेके रखते हैं कि एक में अगर सप्लाई चला जाए तो दूसरे से कनेक्शन ले लेंगे. तो ये थ्री फेज जो वोल्टेज लेवल होता है वो 440 वोल्ट का होता है, राइट? सो नाउ वी विल टॉक अबाउट आरएमएस वैल्यू. तो ये जो भी है सब आरएमएस वैल्यू है वोल्टेज. So the effective value of voltage and current over the whole cycle is known as the RMS voltage. So in जैसे कि पहले अभी पीछे वाले स्लाइड में देख रहे थे कि V is equal to Vm sin omega t था सप्लाई. तो Vm was the peak value. ये जो था this was the peak value, maximum value of voltage wave. So if maximum value of the voltage wave is given, then you can easily calculate the RMS value just dividing it by root 2, right? So RMS value will be Vm by root 2. Similarly, RMS value of the current will be Im by root 2. And in this way, the RMS values are defined. So RMS value of an alternating current is that steady state current which when flowing through the given resistor for a given amount of time produces the same amount of heat as produced by alternating current when flowing through the same resistor for same duration of time, right? तो ये डिफिनीशन से थोड़ा कॉम्प्लेक्स लग सकता है तुम लोगों को कि ये क्या इतना लंबा चौड़ा इसमें बता दिया गया है, बट you can understand the concept of RMS value and this average value with the help of different examples, right? जैसे कि मान लो कि फॉर एग्जांपल if I give you one simple circuit, कि जैसे तुम लोग इलेक्ट्रॉनिक्स में होता है कि इलेक्ट्रॉनिक्स में हाफ वेव रेक्टिफाइड सर्किट होता है, फुल वेव रेक्टिफाइड सर्किट होता है। तो अगर ये इस तरह का वेव फॉर्म कुछ दे दिया जाए तुम लोगों को कि मान लो कि एक हाफ वेव रेक्टिफाइड सर्किट है इस तरह का, इस तरह से कि जो हाफ साइकिल है, in that half cycle only we are getting the supply, and in the negative half cycle you are getting zero value। इसी को हाफ वेव रेक्टिफाइड सर्किट बोलते हैं। इस तरह से वेव फॉर्म हो, तो ये अभी पढ़ भी रहे होगे हो सकता है तुम लोग। तो इसका बोल देगा कि कैलकुलेट द आरएमएस वैल्यू ऑफ हाफ वेव रेक्टिफाइड अल्टरनेटिंग करंट सिस्टम। तो you should know how to calculate the RMS value, right? तो बताओ कैसे कैलकुलेट करोगे? ये सब पहले से पढ़े हो कि नहीं पढ़े हो, ये बताओ।
फंक्शन का सर स्क्वायर करके एवरेज लेके फिर रूट ले लेते हैं।
हाँ, तो ये सब बताओ कि पहले से तुम लोग पढ़े हो कि नहीं पढ़े हो, ये हमको
Yes, sir.
बताना है डिटेल में या क्या करना है?
सर पढ़े हैं हम लोग।
ओके, तो इसमें अगर किसी को कोई कंफ्यूजन हो तो बताना, वी विल ट्राई टू कवर दैट आल्सो, राइट? तो इसमें जो है सो ज्यादा मेरे ख्याल से डिटेल में मुझे नहीं लगता है जाने की जरूरत है, क्योंकि ये सब बेसिक चीज है, आरएमएस वैल्यू, एवरेज वैल्यू। तो अगर फिर भी कुछ दिक्कत हो देन वी कैन ऑलवेज डिस्कस दैट। सो all the meters normally indicate RMS quantities, and this value is equal to the DC value. So as per the definition of the RMS value of the voltage and current, so this is the same thing, both resemble the same thing, right? So now the another example or case you can see here is when inductance is connected to the AC supply. In the first case we have seen that when resistor was simply connected across the AC supply. So same analysis here you can see when just a simple inductor having inductance value L is connected across the voltage supply V is equal to Vm sin omega t, right? So you know that वोल्टेज अक्रॉस द इंडक्टर जो कि अभी VL से हम लोग मेंशन किए थे, सो दैट विल बी सिंपली माइनस एल डी आई बाई डी टी, राइट? ठीक है, तो व्हेन यू विल टेक द मैग्नीट्यूड ऑफ दिस VL, देन दिस विल इक्वल टू एल डी आई बाई डी टी। सो यहां से V दिया हुआ है, तो यू कैन इजिली कैलकुलेट द वैल्यू ऑफ I बाई इंटीग्रेशन, ठीक है, बाई परफॉर्मिंग द इंटीग्रेशन। सो यू विल सी दैट when we have considered this value V is equal to Vm sin omega t or 2 pi ft, then after calculation of the current using this relationship V is equal to L di by dt, you will get this relationship between I and the peak value of the voltage. So you can see that the current is lagging by 90 degree with respect to the voltage, right? तो इसीलिए जो है सो हम लोग जो अभी इससे पहले वाला केस देखे थे जिसमें we have considered the RL load both simultaneously in the system, so we have considered that जो करंट था वो VL से 90 डिग्री से लैग कर रहा था, तो यही माइनस 90 जो आता है, that is the reason, that is for a purely inductive load. Purely inductive means only inductance is present in the system. So we have already discussed it that current will lag the voltage by some angle. Here that angle will be 90 degree because it is a purely inductive circuit. ठीक है, ये समझ में आया सबको?
Yes, sir.
Okay. Now third case, what is considered here, in this, hello, okay, so in this third case you can see that across the capacitor is connected across the same voltage source, which is V is equal to Vm sin omega t. So from here, you can calculate the or you can estimate the relationship between the voltage and the current that will flow through the circuit. So you know that I is equal to क्या होगा? हेलो,
यस सर।
हाँ, तो जो करंट होता है Q, अच्छा जो चार्ज होता है कैपेसिटर के अक्रॉस तुम्हारा Q इज इक्वल टू CV होता है, राइट, एंड I इज इक्वल टू योर dq by dt, right? So from here you will get C dV by dt. So I is equal to C dV by dt, that is current flowing through the capacitor will be equal to C dV by dt. एक मिनट जस्ट होल्ड करो। हाँ वो हम बनाएंगे, सेटिंग बनाएंगे। Okay, so I will be equal to C dV by dt. So V is given Vm sin omega t. So after performing this analysis, means differentiating, you will get that I is equal to this omega C Vm sin omega t plus pi by 2. It means that what does it mean? That this current will lead the voltage by, in this diagram you can see that the current is leading the voltage by 90 degree. As it is a purely capacitive circuit, that's why there is a 90-degree lead of the current, right? And similarly the voltage and current waveforms are also drawn here. This is the phasor diagram, phasor, and this is your waveform of voltage and current. So again we have considered here the voltage waveform. So you can see that current is leading the voltage by 90 degree. So this case we have already considered, discussed that when a resistor and inductor both are taken the circuit. So for this circuit, the net voltage V will be equal to V.
Sir, your voice is breaking, sir.
So these things we have already discussed, and
Sir,
the
your
total
voice is lagging.
impedance
Sir, your
of
voice
the
is
circuit
lagging, sir.
will be Z is equal to R plus J omega L. ये सब ठीक है। तो इसमें जो है सो यही है तुम्हारा जो है सो करंट वोल्टेज। सो नाउ हेलो,
यस सर।
हाँ तो ये अगर तुम लोग समझ गए हो तो इस सर्किट में जो ये सर्किट दिया हुआ है इसको नोट करो एंड यू कैलकुलेट द आरएमएस वैल्यू ऑफ करंट आई।
सर
आई आरएमएस कैलकुलेट करना है।
हेलो
हाँ
सर।
बताओ।
सर आपकी
Yes.
वॉइस कट रही थी, तो आप पहले जो समझाए वो समझ में नहीं आया, एक बार रिपीट कर दीजिए।
Okay. So here we have I have just repeated the same thing, that after discussing a purely resistive circuit, we have already discussed about the RL circuit when RL load is present in any AC circuit, single phase AC circuit. So we have discussed that the combined voltage or net voltage will be just the summation of these two voltage, that is voltage across the inductor and the resistor, and net impedance or complex impedance of the network will be the summation of the resistor value, resistance value, and the inductive reactance value XL, right? तो ये हम लोगों ने सिर्फ डिस्कस किया। इसके फेजर डायग्राम के बारे में तो हम लोगों ने पढ़ ही लिया, ठीक है। तो नाउ आई एम टेलिंग that for this circuit, a simple RL circuit, series RL circuit, you have to calculate the RMS value of current. तो इस सर्किट को नोट कर लो, ये तुम लोग खुद से बनाओगे, आंसर भी यहाँ लिखा हुआ है। सर्किट ड्रॉ करो, you have to calculate the RMS value of current. It's a very basic thing. ड्रॉ कर लिया तुम लोगों ने? Have you drawn?
Oh, sir.
Draw it. अच्छा, मैं एक क्वेश्चन इस पे लिख रहा हूँ, वो भी तुम लोगों को खुद से बनाना है। If V is equal to 141.4, ये भी नोट करना तुम लोग, साइन ओमेगा टी माइनस 2π/3 volt, and current is equal to 7.07 sin omega t minus π/2 ampere, where omega is equal to 314 radian per second. Then first part is draw the phasor diagram of the circuit second is use polar notation to calculate the impedance with phase angle हेलो,
यस सर।
Yes, sir.
अच्छा ये नेटवर्क का इशू आ जा रहा है बार बार। ये देखो अभी स्क्रीन पे दिख रहा है क्या?
Yes, sir.
ओके, तो ये मैंने एक क्वेश्चन लिखा है, इसको भी तुम लोग नोट डाउन कर लो, इसको भी बनाओगे। इसका फेजर डायग्राम बनाना है। V is given, मतलब the instantaneous value of voltage and current, instantaneous voltage equation and current equation is given. You have to draw the phasor diagram of the circuit for this voltage and current is mentioned, and then you have to calculate the impedance, means total impedance of the network in the phasor form. Means just you don't have to calculate the magnitude, you have to calculate the impedance with phase angle. And then in the third part you have to calculate the average power and power factor of the circuit, right? तो इससे क्लियर होगा कि what you have understood through this phasor diagram. तो ये जब बना लोगे, और एक तो सिंपल अभी सर्किट अभी स्लाइड पे दिख ही रहा है, इसका भी कैलकुलेट कर लोगे, then we can proceed further. अब ये
Sir,
बताओ कि
omega
अभी
3
जो
and
क्लास, हाँ
omega 314 है.
हाँ 314, इसमें अब ये बताओ कि अभी जो लास्ट 2-3 क्लास छूट गया, उसका कुछ एडजस्ट करना पड़ेगा क्लास, तो ये कब किया जाए? कोई फ्री स्लॉट बताओ, उसमें कुछ रिशेड्यूल करें क्लास को। हेलो,
सर कल कल कुछ स्लॉट्स फ्री हैं सर, बट
सर
EC1
हाँ
और
सर,
EC2 के. यस सर. सर बट EC1 EC2 के अलग अलग फ्री हैं, तो सर एक बार मतलब वो करना पड़ेगा, मतलब बच्चों से पूछना पड़ेगा EC1 वाले. ये सर.
देखो एक बार कोऑर्डिनेट कर लो तुम लोग आपस में।
ओके सर.
अच्छा,
सर मैं
इस
आपको
क्लास
मैसेज
का
मैसेज कर दूंगा सर.
सीआर कौन है?
सर मैं ही हूँ सर, आयुष मिश्रा.
आयुष मिश्रा। चलो
यस
ठीक है
सर.
आयुष, तुम अपना कांटेक्ट नंबर जो है सो मुझे इसी में चैट बॉक्स में भेज देना अभी,
ओके सर. ओके
और
सर.
जैसा हो वैसा मुझे इन्फॉर्म कर देना। अगर मेरा स्लॉट भी उस टाइम फ्री रहा तो हम लोग अरेंज कर सकते हैं, अदरवाइज सैटरडे को इफ यू आर इंटरेस्टेड देन वी कैन डू दैट, बिकॉज सैटरडे इज फ्री। तुम लोग का तो सारा स्लॉट खाली होगा सैटरडे को।
यस सर.
तो जैसा भी हो, मतलब 1 घंटे का 2 घंटे का करो, ताकि हम लोग जो मिस किए क्लास वो कंपनसेट किया जा सके। ठीक है,
ठीक ठीक है सर. ठीक है.
ओके देन, थैंक यू। Thank you everyone. I will end this meeting now.
थैंक यू सर.
Thank you, thank you.
Thank you, sir.
थैंक यू सर.
Thank you, sir.
Thank you, thank you.